Creating your own designs for personal or commercial use and making money from them has never been easier than it is today. In this video, I'll show you step by step how to create your own 3D models in a very short amount of time without needing any advanced design skills. On top of that, you'll receive a lifetime commercial license for the magnetic chess set we're creating together today. That means you're free to sell it and profit from it. I'll also show you how to smooth your 3D prints to achieve a high quality, glossy finish. With the Snapmaker U1, multicolor 3D printing is now faster, more affordable, and easier than ever before. Thanks to modern AI-powered tools, you no longer need to be a designer to create professional-looking results. For quite some time now, I've had a problem, and that is the cost and print time of multicolor models. Even though I'm a Bambu Lab fanboy and have been using several Bambu printers for a long time, color changes simply consume too much filament. As a result, production is often more expensive than with competing solutions. Then there are the electricity costs. Longer print times mean the heated bed has to stay hot much longer, and with electricity prices in Germany, that becomes expensive over time. And this is exactly where what is currently probably the best alternative for me comes into play. It allows me to significantly reduce print times and with that, the overall production costs of my models. In a moment, I'll show you how to cut those costs dramatically. Right now, I'm focusing a little more on the magic, the gathering TCG, and creating a small golem-like sculpture that doubles as a deck box for 100 cards. Models like these sell extremely well, especially in the United States. Since I sculpt my own models in Nomad Sculpt, modern software has made it unnecessary for me to spend several days working on a single design. Tripo handles a large part of that work for me, but we'll get to that in a moment. This deck box now holds exactly 100 double-sleeved cards, the perfect number for a commander deck. Do any of you play Magic, The Gathering? If so, what deck are you currently playing? If you show up at a tournament with a deck box like this, it's definitely going to turn some heads. Once inside Tripo Studio, I select the option to create highly detailed models. There is a lot to explore here, and some of it we won't even need for 3D printing. What's really interesting is that you can create 3D models from images or generate completely new models from a text prompt. This means you don't need any additional AI programs. Let me show you a quick test using a Pikachu Pokemon wearing a dress. You can adjust the geometry depending on whether you want a low poly model or one with a higher polygon count and finer details. I'm leaving it at 1 million polygons. The segmentation feature, which allows the model to be generated in separate parts, is also available. This can make coloring the model in the slicer much easier since it already consists of individual pieces. For 15 credits, the generation starts immediately. By the way, you can try the software for free first to see if you like the results. As a subscriber, you can also rerun the model generation at no extra cost if you're not happy with the outcome. Just seconds later, we already have a model like this. Enough testing. Let me show you how I created my first deck box. I haven't tested the text-to-model feature for this project yet, so the images I'm using came from another AI program. I start the generation process and a short time later my model is ready. The cut for the lid and the box, as well as the slots for the magnets, are then created inside the slicer. A similar product for MTG. Since Krenko Mob Boss is currently one of the most played commander decks, you obviously need a deck box like this. The best way to show the difference compared to the Golem deck box is that this model already uses 3 colors from the very first layer. That means the entire model requires a huge number of filament changes, and with this particular model I honestly became a Snapmaker fanboy. This is a sponsored placement, that's absolutely clear. But what I'm saying here is my honest opinion. I spent a long time collecting Maker World points to get the Bambu Lab H2D because of its dual nozzle system. But since receiving this printer, I won't be buying the H2D anymore. I had already seen several videos about the Snapmaker, but I originally wanted to stick mainly with Bambu, especially because of the print quality. And now let's get to the real advantage. This is the amount of filament waste produced by the Snapmaker, and here for comparison is the filament waste from Bambu Lab printer using the AMS2 Pro. The difference is absolutely massive when you're dealing with this many color changes on a 3-color model. I've done a direct comparison using the exact same settings. On the Bambu printer, this print takes 1 day and 17 hours and consumes 934 grams of filament. The Snapmaker completes the same print in just 1 day and 1 hour. While using only 575 grams of filament. That means I'm saving 16 hours of print time and around 360 grams of filament. On top of that, there's the electricity cost of keeping the heated bed up to temperature for an additional 16 hours. I don't want to speak negatively about Bambu Lab. I love these printers. But in my opinion, they missed an important step when it comes to multicolor printing. As of today, I believe Snapmaker has positioned itself better than anyone else in this area with the U1. Back in Tripo Studio, I want to take a closer look at segmentation, which is important for many models and especially for multicolor printing. With the Ultra Mesh feature, we can create models with up to 2 million polygons. This is really more suitable for resin printing, where you want a lot of fine detail. It also costs more credits and takes longer to generate. Now let's talk about segmentation. Based on the model's details, Tripo automatically determines which areas should become separate parts. There are 3 different settings available: simple, balanced, and detailed. If you hover over the question mark, you'll always get an explanation of what each option does. Let's select detailed. In this case, we end up with more than 15 individual parts, but they still function as a single model, which is important for 3D printing. A few minutes later, the model has been divided into quite a large number of separate parts. Since this particular model contains a lot of detail, it ended up generating many individual pieces. I can select, move, edit, and manipulate each part independently. If someone plans to use a model like this as separate pieces for a printer that can only print in one color, those parts will usually need to be voxelized or repaired in software such as Blender or Nomad Sculpt. Otherwise, they may only exist as thin shells rather than solid individual objects. It's absolutely possible, but explaining the full process would be beyond the scope of this video. Now let's move on to multicolor printing. There are 2 ways to export a model with color. Things can get a little confusing if you're not familiar with the different file formats. A direct color export for Bambu Studio isn't available yet because we haven't actually assigned any colors to the model so far. If color isn't important to you, and you simply need the segmented model as a complete object, you can export it as an OBJ file. Inside the slicer, you can then use the fill tool to color the model very quickly. However, this only works as well as Tripo's segmentation. If, for example, a small fingernail wasn't recognized as a separate object, the fill tool won't color it correctly. In those situations, you'll need to paint those areas manually. For models with clearly defined details, the process works quite well, but some manual cleanup is almost always required. There is another workaround though, and that's using textures. Textures are usually intended for animations or rendered images, but they can also be useful for 3D printing. I'm going to generate the texture directly from the same image that was used to create the model. The resulting texture is incredibly impressive. Not long ago, professionals would have spent a huge amount of time creating something like this, and now it's done in just a few minutes. Until a direct export function for Bambu becomes available, let's test the FBX file. UV packing should be enabled at the bottom. What's interesting is that I can't import this file into Snapmaker Slicer, but I can import it into Bambu Studio without any problems. During import, I can choose how many colors should be used. I'll set it to 4 colors, even though my model will eventually be printed using only 3. This is what the result looks like without any manual adjustments. You can still change the filament assignments, but there's definitely a lot of work left to do. The texture itself turned out really well. Now let's look at the export function for Bambu. The slicer detects far more colors, and I don't think anyone wants to print a model like this using 16 different filaments. Even with this method, a significant amount of color cleanup is still required. I spent more time exploring Tripo Studio and found 2 possible approaches. One option is to paint the model directly inside Tripo. In the end though, the result is fairly similar to what you can already do inside the slicer. In my opinion, the best alternative is the Smart Mesh feature. I set it to 20,000 polygons. The model isn't exactly low poly, but it contains far fewer small details. After generating the model again, you can clearly see the polygon surfaces. I then apply another texture generated by Tripo and import the file into the slicer. From there, I can color the model relatively quickly using either the fill tool or the individual polygon faces. Unfortunately, this is currently the best workflow if you want high-quality multicolor prints without spending too much time. Tripo's textures are excellent, but when it comes to multicolor 3D printing, the workflow still isn't fully refined. In the end, you still need to put in a fair amount of manual work. With the Snapmaker, I started a small-scale production setup at home. Reducing the cost of my multicolor prints? Check. Reducing print times? Check. Now let's talk about heated bed costs and of course upgrading my printer. Since I definitely want to keep it, I was still missing the ability to print materials like ABS. So I needed an enclosure. It's not the most attractive solution, but somehow all printers with multiple print heads look a little unusual. The enclosure is mainly there to help keep the build chamber warm. I also installed the Panda Breath upgrade, along with two custom 3D printed side panels that can be downloaded. It sits at the very back of the printer. Unfortunately, the rear window is now covered, but it's still a really cool upgrade. To run the heated bed at lower temperatures, I chose the Frostbite build plate. However, for the Snapmaker, I went with the Glacier build plate because I want to print ABS on it. Snapmaker and ABS printing, some people still say it can't be done. Well, I tested it here and it worked extremely well. For my first print, I still set the heated bed temperature quite high because I was worried that the ABS might shrink. Later on, I can reduce the temperature even further. The chest pieces turned out great and the support structures are very easy to remove. By the way, I'm currently creating a magnetic chest set where everything can be stored directly inside the chessboard itself. That makes it perfect for taking on the go. And if you'd like to support me, you can purchase it and receive a commercial license from me, allowing you to sell it anywhere. Now all that's left are the black chess pieces. And you might be wondering why I'm printing them in ABS instead of using an easier filament. The reason is that I plan to make the pieces glossy. The chess pieces are printed in ABS and the pocket for the magnet is placed right in the center using the slicer. First, I had to test how many layers of filament should separate the two magnets inside the chessboard to achieve the perfect magnetic force. I tested everything from 1 to 4 layers at a layer height of 0.2 mm and finally settled on 3 layers, which equals a distance of 0.6 mm. This gives the board a clean surface while providing the perfect magnetic strength for my magnets. Now it's time to glue in the magnets. One important thing to remember is that every magnet in every chess piece must face the same direction. To make that easy, I build a small stack of magnets and always take the top one. After that, I test every single chess piece once more to make sure all the magnets are installed with the correct polarity. While the chessboard is printing, I smooth the chess pieces using acetone. I place the pieces inside an airtight container together with paper towels soaked in acetone. As the acetone evaporates, it creates a chemical reaction that slightly melts the surface of the ABS, making the print layers disappear and leaving a glossy finish. It's important to print these models with more than 2 walls because otherwise they can collapse if they're exposed to the acetone vapor for too long. After about 1 hour, this was the result. I did notice one small mistake though. The softened filament had started sticking to the wooden surface. That's why I stopped the process a little earlier before the pieces bonded to the wood too much. It's better to do this on a metal surface or on plastic film instead. The lower part of the pieces is already nice and glossy, while the upper section still shows a few print lines. Another 20 minutes would probably have produced the perfect finish. On the chessboard you can still see the black circles where the magnets are inserted. In the version you'll be able to download, those circles will also be white, so you won't see any dark spots showing through like on mine. Some of the chess pieces came off without any problems, while others, just as I expected, had bonded slightly to the wood. Those required a little more force to remove. The chessboard has now finished printing and it looks great, except for the areas where the black filament is slightly visible. Next, I remove the support structures and glue the magnets into place. Once again, it's very important that every magnet is installed in the same orientation. I use my little magnet stack again, always taking the top magnet. I keep testing with one of the chess pieces to make sure everything sticks correctly. Perfect. Finally, I test every single square on the board. To make this a true travel chess set, I also designed inserts with cutouts matching the shape of each chess piece, so everything can be stored inside the board. With a little pressure, everything fits perfectly and nothing moves around anymore. And this is how you can create many more figures at once while saving a lot of time. Besides the standard method of uploading a single image, there's also a 4-view option. Here you upload one image from each side, allowing the model to be generated correctly from every angle. For a chess piece though, that's not really necessary. So let's move on to the next feature. Since I want to create several chess pieces, I'm using the batch function, which saves me a lot of work. Instead of uploading every model individually and configuring the settings each time, I can apply the same settings to up to 30 models at once and upload all the images together. Chess pieces really only need around 5000 polygons since they aren't highly detailed, although I'm using a little more here. While the models are being generated, here's a quick tip for creating some fun custom models. Simply use the text to 3D feature. For example, I want a chess piece designed as a dragon, so I just type a short prompt, and that's exactly what it creates. It turned out really well. Now I'll simply replace the word dragon with Pikachu, and just like that, you can create your own Pokemon chess piece. In my opinion, this is the perfect chess set. I'm going to give it to my son, who's currently learning how to play chess. And as you can see, getting glossy chess pieces is no problem either. With Tripo Studio, you can create your own custom game pieces for chess, Monopoly, or almost any other board game in just a few minutes. Software like Tripo Studio is perfect for makers who want to bring their imagination to life. And paired with the Snapmaker U1, multicolor printing is simply a lot of fun. Score 500 free credits right now through the link below. Want more? Use code TripoCrew to get your first pro month for under $8. That's 60% off. You'll find all the download files in the video description, and if you purchase anything, you'll also be supporting my channel. Thank you.